welcome everyone to our Australian Standards Analysis webinar. Mario is our guest speaker from Innovezza. With 30 years of experience in construction design and consulting, Mario brings a unique blend of construction understanding and design innovation. So we appreciate your taking the time to join this webinar. We are recording it for everyone's reference after the webinar. So a comparison of the use of reinforced concrete for small swimming pools, the 1992 versus the 2025.
Terrific. Hopefully everyone can hear me and can see our presentation. By all means, just say something in the chat if there's an issue. We do have an ability to ask questions, so I encourage anyone to ask any questions they would like. If I can't answer them immediately, then I'll take that on notice and get back to you and provide you with a response. Okay, so what we're doing today is we're going to be talking about the the Australian standards being AS2783, the 1992 version, which was the old version, versus the current version, which is the 2025. The objective of this seminar is to set out the differences and requirements by the change in the revision. These impacts will affect the structural design and construction of swimming pools with pneumatic or shotcrete application reinforced concrete, either wholly or partially in the ground. This presentation won't be a line-by-line comparison of the two revisions, because I think that would just bore everyone to death, but it will highlight some of the major and significant changes which may impact construction or have construction implications and therefore cost implications. The scope, which is the definition within the scope, has been modified in AS2783, and it is a very important difference that needs to be discussed right up front, and that is the 1992 code included pools which were formed and poured in situ, as well as pneumatic applied pools. It really covered everything, whereas this code applies primarily to pneumatically applied reinforced concrete pools, which is shotcrete pools. It does state in the code that it doesn't apply to formed or cast concrete pools, but in my opinion, it can be used as guidance for those formed and cast, but you would then need to refer back to AS2600 or AS3537. But we will talk about that a little later. The major changes being that obviously applies to pneumatic concrete only. The requirements affecting durability, pressure relief valves, drainage layers, steel reinforcement, concrete, and equipotential bonding have been updated, and it would be worthwhile having a look at from a constructability point of view to go through and look at the changes with equipotential bonding and also drainage layers. I'll be obviously the engineering design will be impacting the steel reinforcement and of course steel fiber. There's an update in the design life and maximum surface area of pools. That's the water surface area. And the terms and definitions have also been updated. So it is worthwhile going through and just making sure that you're across those items. Okay, key changes. Well, let's get into it. So it's what we're all here to do. The overall length of the pool, which previously talked about not being greater than 16.7, this is the 1992 version, 16.7 metres or less than 100 square metres, whereas the new code allows up to 16.7 metres in length and 16.7 in width. So that's actually quite a significantly increase in surface area. If and also it excludes the above ground sections of formwork. It does take, the new code does take precedence over the AS3735 if there is a conflict for the pools that fall into the application of the new code. So in other words, if the pool is 16.7 meters in length or in width, then then AS2783 will apply. If it doesn't, if it's greater than that, then it will be AS3735. There will be no conflict. But if it sits within the 16.7 meters, then the code will take precedence. The AS2783 shall take precedence. Also, clause 3, which is the reference documents, have changed. So let's move on to the next one. There are now previously the 1992 version didn't reference other codes. This one does, specifically AS2870, which is residential slabs and footings. And by way of explanation, residential slabs and footings refer to primarily the soil classifications being from A, S, M, H1, H2, D, and E. Now, most of you hopefully are getting soil reports for all your jobs that you're currently doing. And those soil reports will refer back to AS 2870, and the new code does refer to it. Therefore, it takes into consideration those site classifications in terms of the treatment and design of those pools. It also refers to structural design in terms of earthquake to ensure that we don't end up in a situation where during an earthquake a pool will fail. I must admit I have not seen too many pools that have failed due to earthquake. Usually they are actually used as dampeners in high-rise, but obviously there has been cases where a pool has been on different bearing capacities. There's also the liquefaction of soils under a pool during an earthquake that would be applicable, and this would be something which is probably more applicable in the New Zealand areas in New Zealand, but there are quite a few areas in Australia where it would apply. And it also refers to AS4778, which is actually the Earth Retaining Structures Code, which, funnily enough, is pretty much describes a pool, because when you think about it, the pool is a liquid retaining structure, but it's also an earth retaining structure. So the engineers need to take note that the above changes will impact the design process. You will need to go through and check those particular codes to make sure that you comply with all of them. In terms of impact to cost, this could mean additional reinforcement, could mean that you need to have propping through construction. There can be. So you need to make sure you work with your engineer to get what the difference will be for your particular pool design. Right, additional sections as well. Aggressive soils. There is a specific reference to acid sulfate soils, which is which with a sulfate concentration of more than 1,000 parts per million. The determination of the salt concentration is normally conducted as part of the soil investigation and associated testing. This is actually very common in New South Wales, and it's done on most soil reports. And it is where most of the acid sulfate soils have been found in the past. It's been included in this code, so therefore it's more likely now to become a requirement in other states. It's actually not in AS, it is in AS 2870, but it hasn't spread to, in terms of housing, hasn't spread to the others too much to the other states, but it is a requirement. The impact of it is normally that you end up with more cover which is not always an issue with pools because we usually have excess cover. But the fact of the matter is it should be considered because it can lead to, this is what can lead to concrete cancer. The code also defines what a competent person is. This is defined as the person who has the required knowledge and skill required to perform the task required. Example, a professional engineer who is a corporate member of the Institute of Engineers. So for myself, I'm a CPEng. I'm also a fellow of the Institute of Engineers. I've got many years experience in design, therefore I qualify as a competent person. I'm sure if you talk to some others, like my wife, she probably won't agree, but anyway, luckily she's not the judge. Had to throw that in there. Okay, clause 4.8, small swimming pools. Overall, again, the dimensions of the pool, which is 16.7 meters in length and or width. The design life, this is an important distinction, is 30 years. For 50 years, refer to AS3600 and AS3735. So both those codes, AS3600 and AS3735, which are more directed towards commercial designs, does have that 50-year design life, whereas the small structures pool only has 30 years. Now, that's not guarantees. That is a design life. So the design life is really saying, okay, it's designed with regular maintenance and proper care and, meeting the CSIRO requirements and all those kind of bits and pieces. The design life of the pool will be 30 years. So it's not a warranty or anything like that. So don't get it confused with warranties. But what it is, it's about design life. It's what the design of the pool has, what the engineering design of the pool is targeted for. Some terms and definitions have been updated. For example, containment of disinfected water with pH not less than 6.5, salination not greater than seawater, no dimension greater than 16.7. These are, or 1/3 of Olympic size pool. So there's been some clarification of definitions which you will need to get your head around. Section 6.3 and 6.4. They've not really changed. 6.3 really hasn't changed from the original documents, but 6.4 has, with 2 additional items. The first additional item directs the engineer. Site instruction reports and statutory building surveyors reports are to be retained by the builder. So what that's saying is, if either the building surveyor or ourselves come out there and do inspections or anything like that, those documents must be retained by the builder. And I think that is actually for a 7-year period. That's like the normal requirement. But if I were you guys, I'd be probably maintaining it for at least 10. The second is that the reports should be available for inspection during the process of the work and for the duration of the warranty period after the completion of the work. And the warranty period is usually 10 years. So you need to hang on to those. It's all about maintaining proper paperwork for the construction of the pool. Okay. Section 7, general design. Minor changes have been made. Additional forces. Now this is about expanded via note 1.1 to 3, which is essentially takes into consideration the fact that the pool is a retaining structure. So not a major. It's a minor change. It's just adding a bit of clarification. Now, major change, and this is a major change, is the effective cantilever height of the pool and how it is designed. Previously, what you see on the left-hand side there, which is the 1992 figure 1, which is the effective height, which from an engineering point of view, the design is based upon, was taken from the top of the pool level, not from the water level, but from the top of the pool level, down to where it intersects with a radius at 60 degrees of a curve. So that was HE, and that was applicable whether you had as long as you had a radius at the base, and whether behind the radius the excavation was a square edged, or whether it was or fully exposed or fully embedded in the ground. This is a major change, because what's happened now is that the effective height is now pretty much the full height of the pool, and it doesn't take into consideration the fact that you have a radius. Now, personally, I didn't particularly agree with this, but this is the consensus of the pool of the code committee. What this will do is it means, as you can see from the diagram, it will mean the effective height shall be greater, and therefore the reinforcement that's going to be required will most likely increase, and that is due to strength. Now, most pools don't have the strength is not always the governing criteria. In fact, it's very rare that it is the governing criteria. But because of this change, strength may well become a governing criteria, and you must take that into consideration. So most pools would have, say, N12s at 300 centres as your standard pool depth. That may no longer be the case. You may find that will reduce down to 250 or even as much as 200. So be aware of that, and please take that into consideration with your costings. Other changes, key changes, being 7.4.3, which is the stability against uplift. Now, in the new code, it requires a minimum safety factor of uplift of 1.33 rather than the previous limit of 1.1. By way of explanation, what that means is that previously you needed to allow for, say, 10% of actual weight of the pool that's empty with pressure from the outside. So with the pool fully embedded in material, in founding material, which is fully saturated, therefore it's got a full hydrostatic uplift. It needed at least 10% more weight to keep it in the ground. Well, now the code is requiring that be 33%. Now, that will most likely result in additional weight, additional concrete that you will require to allow for. This is for both construction and in-service conditions. So, in my experience, it's the construction, which will be the worst case. That is when the pool is empty, and therefore it's not that. Therefore, it's the case where you're not having to you're having to lift the just the pool shell, but the water as well. So the in-service condition won't be the worst. It will be the construction. The assessment of the uplift safety factor to refactor may result in anchoring systems, additional drainage layers, and potentially pressure relief valves, or any combination of those three. This will be, again, the judgment of the competent person. Now, this is, again, durability. There's a table change, and there's expansion to include surface. So this is what the table actually showed back in 1992. As you can see, it's fairly straightforward. What it does is the exposure classification that you're looking for here is the little table, which is the column that's in the middle. So obviously, what you do, if you're what you would find, say for example, most of the pools that we install would find themselves in the near coastal. Most people live within 50 kilometers of salt water, so you'd find yourself in that category. And most pools, as a minimum, would be using 25 MPa as the strength. And of course, and then your exposure classification is B1. That then determines the cover requirements. Now, what that's changed to, it's a little bit more complicated now. You're in whether you're in the surface member is in contact with an aggressive soil or a non-aggressive soil, gives you a certain classification. Whether it's inland, near coastal, there's a whole bunch of new requirements now that need to be considered, and they've actually, and the key one that you want to look at there, the surface in contact with pool water, being a chlorinated pool, saltwater pool, or a seawater pool, and it gives you the various types of exposure classifications. Now, most of the pools that we would be designing would be sitting in the saltwater pool. So this is definitely an increase. It's gone to B2. The minimum strength is now 32 MPa. So those of you who have been quite regularly doing pools at 25 MPa, you're going to find that that's going to increase to 32, and you're probably going to find that your cover requirements are going to be more stringent. So be aware of that. That is a very important, that will be a cost driver for you, but it is definitely something that you need to consider. Okay, materials. So obviously now we've had a few design requirements that we've discussed. Now we're going to get into what the material changes. Now, this part of the code has actually been expanded. The code now specifies the cementitious concrete's content. So that's the cement of the concrete as a minimum, as well as specifying the minimum for curing. Now, this is really quite an important differential. That is that the curing times are crucial, especially for pneumatic concrete. My favorite curing method is Hessian bags with a sprinkler. I've always, having watched my father, who was a form worker for years, and we always ended up with a very good result that always worked out well. But you can use curing compound, but it's a one very important point of when you're using curing compounds, you got to understand that pneumatic concrete is not a smooth surface and which is pretty much what most of the curing compounds assume, that you have a smooth surface to work to, and the curing compounds will find their way into those little points, little gaps, and basically not do the job as effective. So please keep that in mind. Watch how you apply it and make sure you get it in there into those points. It also highlights the difference of high strength concrete, i.e. 40 MPa concrete, and the control of shrinkage for such structures. So essentially, as you get to higher grades of concrete, or you get to pools which are fixed by other structures or other bits and pieces, and they want to shrink or move away from them, it's very important. Shrinkage is a very important component to be considered, both in when you're doing your pricing and costing, but also in design. The code also includes the use of and control of manufactured polylands, which is essentially additives. So we're talking about fly ash and that kind of thing, and their conformance to AS3582.4, which is, and you need to understand that is the code which governs those additives. It's not something which we normally get too involved with. I must admit, it's the only time I think that we've used those kinds of additives is when we're looking at really kind of high, very longer pools with our control joints and what have you, and we want to put some additives in there, and there are some very good products that are out in the marketplace. And there's one which is but I won't bring that up here because that would be not great. The code. So the further change to clause 6.7 is the old code discussed steel fiber within the concrete. In the new code, clause 9.9 clearly states that steel fiber concrete is not currently recommended for construction of swimming pools, which is pretty much, in my view, pretty much an obvious answer. I don't know too many companies that do steel fiber reinforcement anymore, because basically the steel fibers, even though they are galvanized, they do tend to rust. Also, there's a fiber reinforced concrete out there that tends to be tends to be highly it tends to shrink. It depends on what fibers you use. Some fibers tend to be a bit elastic and give you a bit more, but there is glass fiber reinforced concrete available. Reinforced plastic, which is available. You can design it's exactly like a steel bar and can be used exactly like a steel bar with one, well, to the best of my knowledge, one difference, and that is that you have to have these bars actually put into shape, and so that when they get delivered, you can actually just place them in, because you can't really bend them easily over a certain radius. So, but it is a good option to be able to use. So, key point of this: steel fibers are out. Section 10, no major changes between the two codes. Clause 10.2 changed the tolerances on specific dimensions, item D, structural thickness, which is outside, that should read outside, as -5 millimeters. The previous code also had that, but there was no limit to the maximum structural thickness. So essentially, it still is the tolerance being -5 plus whatever it is. It doesn't matter. So in other words, when you're putting your reinforcement in, if you've got some areas which you've had to over excavate for whatever, removal of a boulder or anything like that, you don't have to put extra reinforcement in there. You're still putting your reinforcement to the face of the pull face, and which is in contact with the pull face. What happens behind is just excess cover, and the code allows for that. There's no in sections 11 to 15. There's no fundamental changes in those sections. Section 15, no fundamental changes. It has been broken up, which has made it much clearer, which previously it wasn't. Section 16, which is the detailing of reinforcement. The major change is the use of Y-bar has now been deleted, as the industry no longer uses these bars. I see this in documentation when I'm involved in various cases where documentation has not been updated. Now the code is actually specifying it. It's not giving you a choice. You can't just leave it on there and think, oh well, if they can get it, that's great. No, it's not to be used, well, not to be specified. The designation of 250N, which was previously known as 250S or S bar, is referred to in the code. The shrinkage requirements in the code have not changed from the previous requirements for cantilever walkways for structures more than 900 millimeters above ground level. So it's an important point that needs to be considered. And that's more for you guys that are doing those cantilevered sections above ground. Concrete cover, there's no changes. Therefore, the placement of concrete reinforcement is not changing significantly from the current industry standard. It is noted that the new code refers reinforcement shape and following the internal profile and radiuses of the wall. Right, I think I've exhausted my time. I believe. I think I'm about a minute short. So, if anyone has any questions, I'm happy to answer. By the way, if there's a question I can't answer immediately, I'm happy to come back to you. Because obviously I've got to refer back to the code, but I'm happy to come back to you in writing and provide you with any answers that I can't answer right now. So I'll hand back to Wendy.
Thank you, everyone. And as mentioned, if you have any questions or you have any more comments or requests of Mario, please let us know. We'll be sure to pass that across. Thank you, Mario, again.
You're welcome.
Talk to you soon.
Thank you. Hey, guys.